So thanks everyone for joining. I hope you enjoyed your lunch. So this talk will be about GraphQL in the era of server components. Full disclosure, I mean it's maybe like 10% server components and the rest is GraphQL and why you still might need it today. So in this talk, I mostly want to explain why you should or could still use GraphQL. I'm a big fan myself, but doesn't mean you have to be a fan as well, or that I'm trying to convince you. I'm mostly going to try and show you what need it has today. Now we have server components, which might be a better choice for you if you're building some sort of backend for your front-end app. So is anyone in here using GraphQL? Oh, quite a lot of you are, so that's great. Is anyone in here using server components? Some of you are. And who's using Next.js 15? Okay, I was hoping to see maybe some of you are using server components without knowing it. You're just writing your code and then suddenly you no longer know if it renders on the server, on the client, or maybe somewhere in the middle. So my name is Roy. I used to work at a startup called SnapSam. We were acquired by IBM last year. What we were doing was building GraphQL APIs for any data source, which was kind of cool. Now at IBM, I'm doing more or less the same, but also with a sprinkle of AI, I guess, as most people do today. I wrote some books about React and GraphQL, and you can also find some talks from me on YouTube. I was actually here in 2022, so there might be a recording of my session there. I think it was called something in the sense of React and microservices, which is a great fit, by the way, but more about that later on. So if any of you is looking at the conferences of like Next.js and Remix or ReactConf, which is happening every now and then, you might remember this image of someone building some form, and the form has something in it which is actually doing an insert into a SQL database. I can't actually remember if this was real or it was a parody, but this is something you can do in theory with server components. So with server components, you could connect to a SQL database just from quote-unquote React component. So we've gotten to a place where you can write backend code as easy as you can write front-end code, and everything is sort of mingling together. So if you, like me, wrote PHP, then you probably know how to mix up front-end code and backend code into a single code file. So with server components, you could do something like this. You can actually write server-side code inside of a front-end component. So after this meme or this image was released, people started to say left and right, you don't need GraphQL anymore. Which I guess as everything in software development, it kind of depends. You probably don't need it. It might be useful for your use case, as most technologies we use today. You can think about TypeScript. Do you really need it? You maybe don't, because you can use alternatives like JSDoc. You can do duck typing in your test. You can do all sorts of things, so you probably don't really need it. But it could be useful for your solution. If you think about GraphQL, it can be really useful. It can also lead to overhead for your engineering teams, or overhead for yourself, or maybe overhead for basically all the code you write. But it all depends on your use case. So what I saw people doing a lot, like maybe 2 years ago, it's comparing GraphQL to server components. And you can see the same thing for TRPC. Is anyone here using TRPC? 2 persons are, so maybe you're from the same company as well, or maybe you're not. So I'm going to share a little bit about TRPC later on, but comparing GraphQL and server components is something I see people doing as well, because they might have been using GraphQL wrong from the get-go. So let me show you why I think people might have been using GraphQL wrong. Because comparing React server components and GraphQL is like comparing apples and pears. So I'm originally from the Netherlands, which is in Europe, for those of you that don't know. And we have a saying like something is comparing apples to pears. They're both fruit, could be delicious, they're kind of sugary. They both have pits on the inside or seeds. And they both have a small little bit of skin on the outside. But they're very different fruits. So React server components and GraphQL are also very different technologies. You might be able to reach the same goal, have some sort of backend code for your front-end code, but how they reach that specific goal is very different. So if you think about GraphQL, GraphQL is a API specification. Some people like to call GraphQL like a query language for APIs, or it's almost like SQL for your APIs. So if you think about writing SQL is kind of easy to get a first response. You do a select whatever from this table, and then you expect the results to come in. So even if you're not technical, you're probably able to write a little bit of SQL if you don't think about joins and aggregates and group bys and more complex things you can do. If you think about server components are a specification for rendering HTML server-side, or defining the HTML you want to render server-side. Maybe rendering HTML server-side is not the best sort of description for this, but there's a great talk tomorrow by Dustin to explain you everything about React server components that you won't learn in this talk. So if you're still confused about should you be using GraphQL instead of server components, should you be looking at gRPC, is GraphQL still fit for me, then a question I might have is, are you using GraphQL correctly? And I guess this is something you saw happening online as well. People said, I don't really need GraphQL anymore now that I have server components, or I don't need GraphQL anymore now that we have gRPC. So leads me to thinking maybe people have been using GraphQL wrongly, or sort of the sentiment about GraphQL or why you should use it might be incorrect, or might be people were using it just in a slightly different way than it was intended to be used. So let's look at GraphQL's original intent. So I first used GraphQL somewhere in 2016 when I was at a hackathon in Berlin, and there were some guys there from a company called GraphQL. So they sort of built one of the first popular GraphQL implementations. And they were showing us how to use GraphQL on top of a database, which was all built into some SaaS environment. And it was really cool because you could select the fields you wanted from the API directly instead of needing to write raw SQL. And you can reuse different endpoints across different apps without making changes to the actual endpoint or the path name. So GraphQL's original intent was probably very different for what people are using GraphQL for today. Because if I ask friends, what do you like about GraphQL? A lot of them say it's easy to get started because there's all these developer tools. But there are developer tools for any sort of API specification. And something else people say, I really like the type safety because it makes my front-end apps type safe, which is a nice sort of secondary benefit of using GraphQL, but it's not its original intent. So originally, GraphQL was created by Facebook before it was changed to Meta, because they wanted to reduce transactions between front-end and back-end. There's a really nice documentary about GraphQL, and if you look at the documentary, you see the sort of creators of GraphQL also saying, like, we had all these APIs we were using for our web application. Then we built a mobile application, and we suddenly saw the web APIs were producing too much data for sort of mobile APIs, because the mobile APIs had a limited feature set. If you think about like 2015, 2016, you probably had your first iPhone, or I don't know if Android was there. Maybe Android was there already. But the bandwidth was really slow. It was like being on a train and driving through a tunnel all the time, because your network was really throttled, it wasn't that fast. So they were looking for a way to reduce transactions between front-end and back-end code. And also looking at reducing the amount of data. So not only sending less requests, because requests were throttled and they're all piling up, but also reducing the amount of data being transferred between all those different requests. And then also GraphQL to reuse across multiple apps or applications. Because one thing they saw, they spent a lot of time crafting their APIs for the web application, and then they also found out they almost needed to re-engineer their APIs in order to fit the sort of mental model of the mobile application, because the mental model was very different. So they saw GraphQL as a cool way to reuse the same APIs without needing to rewrite all the things they needed, and only implement it once instead of implementing it in different ways. So when you want to use GraphQL, it really depends on your use case. I think the original intent is still valid in a way if you think about reducing transactions between front-end and back-end. I think bandwidth is really cheap today. Your internet is usually really fast, whether you're using 4G, 5G, or your broadband internet. It's always fast, and you don't really have to worry about the amount of data being transferred because you can probably handle it. Also, if you think about applications nowadays, some of them are really bad. They're transferring images of like 14 megabytes whenever you open a website the first time. So I don't think we have to worry about some JSON being transferred back and forth when people are loading or rendering images of like 14 megabytes whenever you open a web page. So when to use GraphQL today really depends on your use case. So what I see as some of the first uses for GraphQL, people had a database or they had some services and they needed an API on top of those services. This is sort of one-to-one. You might be a single developer or a solo developer, maybe a small team, and you're just powering one application from one API. If you look at this sort of one-to-one mapping of your backend and your front end, you probably don't need GraphQL because it might be overhead. You might be better off changing the REST APIs or whatever kind of APIs you're using to fit your specific user interface, because why would you need a reusable API, or why would you need an API that sort of encourages you to reuse its use when you have a one-to-one mapping and your backend team might be sitting next to your front-end team, or it might even be the same people working on the front-end and backend. So for these one-to-one mappings, I'd say you probably don't need GraphQL. If you like GraphQL or you have a tool to turn anything into GraphQL, then it's probably useful to use because it saves you time. But from sort of GraphQL's perspective, you're probably better off just using REST APIs. So like I said, you either really like GraphQL like myself and hopefully some people in the audience, or you have some tool that makes it easy to use GraphQL out of the box, because these one-to-one mappings aren't the best use case. If you think about another mapping where you still have a single backend, but you have multiple front ends, so this is where GraphQL becomes more interesting again, because you have a single backend that's powering maybe 3 applications, or 2, or 4, or 5. You don't want to rewrite all your API endpoints for each of the specific use cases, but you also don't want to make the API endpoint, let's say for customers, that big that it can power all your different use cases, because one of your applications might be a mobile application where you have a limited feature set compared to web, and maybe your other use case might be an admin application where you're sort of administrating your users or your orders or posts or whatever you have in there. So ideally, you have the same endpoint powering all these applications, but you want to make sure that you're not sharing data or the same data across all these applications, because there might be authorization which you need to take into account, or there might be data in there that you're not using. So this is where GraphQL already becomes more interesting, because where are you going to normalize, combine, and filter data in your front ends? Typically, if you have this setup, one of those front end is going to pay the price for reusability on the backend side, or your backend team is going to pay the price for creating 3 different API endpoints, or for creating a sort of monster endpoint, which is maybe REST-ish instead of RESTful, where you can do filters and tagging and all those things that you probably don't want to be doing. So in this use case, and I found myself quite often in a use case where I got an API from a backend team or a public API that didn't really fit my needs, so I needed to spend a lot of time altering it so it fits my user interface. So this is where I really like GraphQL, because you take away the need for processing data in 3 different ways, for creating endpoints that solve 3 different use cases. Instead, with GraphQL, you would get a sort of single endpoint. So GraphQL really solves this problem, and if you look at it from the next slide, I think here, yeah. So instead of giving users a single REST API, which might have different endpoints per use case, or might have a lot of data in there you don't need, you're going to give them a GraphQL API. And most of you have been using GraphQL, so that's good to know. So let's assume you have a type which is maybe called customers. Each of those different applications would be able to retrieve different fields based on their needs. So as the sort of backend team, you would still implement all the fields. So you would be able to retrieve orders or subsets of orders, or retrieve an email address, or maybe first name, last name. But it's up to the application implementing something on top of the API to determine what fields they need and what fields they don't need. So it gives a bit more control to the people on the front-end side without any actual interference with the backend people. So they don't need to ask them for changes or ask them to rewrite or normalize or combine data. Instead, the power moves to the front-end people and they're able to implement all of this. And especially this is useful when you do federation. So maybe not everyone has heard about GraphQL federation. Maybe if you've been using GraphQL since the early days, it was called schema stitching. So this is where you turn different data sources into a GraphQL API and then use like a super graph to bring all these smaller GraphQL APIs together. So this is where GraphQL really shines. And usefully, you only need this in situations where you might have microservices or distributed teams. So think about GraphQL federation as sort of the microservices of the API world. If you have GraphQL federation, then it would make sense to have microservices underneath. And if your company doesn't want to use microservices, then they're probably better off not using GraphQL federations for similar reasons. So this is like a many-to-many mapping. You have many different backend services, and you have many different front-end services. And you don't want to reuse APIs across different backend services. You don't want to reuse front-ends across different backend services because all of this is going to take time to discuss with coworkers what to do. It's going to take you different sessions or work groups to document what is needed or not needed. And probably if someone is going to change something somewhere, it's going to mess up your code on the front-end or backend side because you have a dependency on their code, maybe without knowing, or maybe with knowing, but not being updated whenever they make a change. So if you think about GraphQL, and GraphQL has schemas. So for those that don't know, on the right you can see an example of a GraphQL schema. So we have a set of types. So there's 3 types. There is product, review, and offer. And then there is a query type. So this is a field to retrieve data. So with this query type, you can retrieve a product with a given ID, and then it will return the product type. And as the end user, like you see in the middle, you can actually determine what fields you want to retrieve and what fields you don't want to retrieve. So all these different use cases can retrieve different fields without the backend API needing to change anything. So the front-end applications get a lot of ease of use because they no longer have to worry about all the data they get. Because one of the things I really dislike about public APIs, typically they're going to give you like a huge amount of JSON and you need to filter out what you need. And typically it's only 1 or 2 fields. So GraphQL solves that problem. It might not be that big of a problem today because, well, internet's really fast and kind of cheap. But if you think about your ease of use and you might have really big applications or a real large set of users, then you can still see the advantages. But the biggest advantage really is not having to rewrite all your code every time you sort of onboard a new application or onboard a new team into building on top of your data. So every frontend can reuse this, which in my mind is really powerful. I see a lot of enterprises doing this already. If you think about Shopify, for example, Shopify is building public APIs, and they're building public APIs to be used by Shopify customers, by people building Shopify templates or plugins. And they actually moved all their public APIs to GraphQL, which kind of shows how useful it is and how it enforces reusability. If a company that big with that many developers building on top of their public APIs, it's going to show that people are moving towards the direction of GraphQL for public APIs where reusability is really important. So you can think about GraphQL in this sense as a BFF. So if you think about BFFs, it's not best friend forever, but it's backend for frontend. I mean, it could be your best friend forever. As a frontend developer, I really like BFFs because you, well, typically speaking, I don't like to take an API that I didn't build myself. So BFFs are a great way for front-end teams to take sort of control of the data layer they might need to build their applications. So GraphQL Connect as a BFF or backend for front-end for the front-end developers without them actually needing to implement something. So this made a lot of sense when GraphQL was invented in 2012, and then it was open sourced in 2015. And in 2015, when they open sourced it, it was just a specification. It was like a Word document or a Markdown document saying GraphQL APIs are doing this, this, and this. So today, GraphQL is still just a specification on its own. But then there's a whole ecosystem around it of like developer tools, of different products built on top of GraphQL, of developer tools for front-end developers, for back-end developers, visualization tools. There's a whole ecosystem of tools you can start using. If you think about server components, they also make a lot of sense today because for all the reasons I mentioned, developers need to work with APIs built by someone else. They probably need some layer in the middle where they can start to normalize this data, filter the data, or combine data coming from different data sources. So server components in a way also act as a small backend for front-end for developers, unless you make it your entire backend and you start to connect to SQL databases. So for me, server components are multiple things. They're either a way for me to render code server-side, which might be faster, or maybe there are things in there which I don't want to share with a client, like maybe environment variables, or maybe code that I don't want to be running client-side for injection reasons, or because I need some sort of normalization layer for my front-end code. So if you think about this setup where you have a single API powering 3 different apps, and with React, in theory, you can write your code once and then run it everywhere, or learn it once and then know how to write code for different platforms. If you have a single API powering 3 different React applications, probably all these applications are using server components to take the data coming from your API and making a sub-selection, filtering, normalizing, doing all these things before you send it to the actual UI. So using GraphQL, you could save you time. As mentioned in the beginning, it's not a replacement or a comparison to server components because comparing them isn't really fair. But you can retrieve the same results. You can get a backend for front-end for your user interfaces. Or you can even use it as your single API. I've seen people do this, and it sort of brings me back to the meme in the beginning where you have React server components connecting to databases, connecting to APIs, connecting to whatever you want to connect to. So you can still do this with server components. It's probably not the most efficient thing to do, but it might be really useful if you're building a small project, you're maybe an indie hacker, or you're building something for fun. So I also need to talk a little bit about tRPC. So tRPC is, in my opinion, quite cool if you're writing your front-end code and your back-end code in TypeScript, because tRPC means TypeScript RPC. It looks a bit like this. You would have a tRPC server, and then you use a tRPC client to retrieve data from your tRPC. And in your tRPC server or client, you're connecting to all these different data sources. So what you do, you create a single TypeScript layer on top of all your data sources, and then your front-end applications are able to use that single TypeScript layer to retrieve data. And this is really cool if you're looking for type safety, if you're developing your front-end and back-end in TypeScript. So it's great for end-to-end type safety, which is a great thing to have. It's also useful if you have a single code base. So if you have this one-on-one setup, where you have maybe one web application and one backend, it makes sense to use tRPC if TypeScript is your language of choice, because you can reuse all the types, you can reuse all the different data models. But if you have multiple front-end apps, it already gets a bit more complex. You can still reuse the TypeScript types, but you might be creating generic types that are really big because you're serving multiple applications, or you're creating specific types which are really specific again because they serve a single need. There's always some sharing you can do, but it might get complex at some point. As opposed to tRPC, GraphQL is great for querying multiple data sources. So tRPC, you can use it for multiple data sources, but there's no federation concept where you turn every data source into an API and bring it together in a bigger schema. And GraphQL also allows for decoupled services. So if you're using tRPC, you're kind of linked to TypeScript, and all your different projects which are delivering backend code, they either need to be wrapped with tRPC or they need to be written in TypeScript. So with GraphQL, you can actually decouple services and you connect them on the API level. So it doesn't really care about what kind of underlying technology or framework you've been using. So again, it's a good to compare them, but they serve different needs. Although the end result might be similar. I've recorded a video about using gRPC, compare it to GraphQL a while ago. So if you're interested, then you can scan this. There is a link to a blog post somewhere there as well. Give you a few more seconds. Okay. So gRPC, in a way, is much closer to React Server components than GraphQL. Because with gRPC, you create something usually on the sort of front-end / back-end side. It's much closer to your front-end code, and it's also much more specific. And actually, you're pulling in dependencies from gRPC into your front-end code. So it's really closer, really much closer than GraphQL is to React Server components. So I talked a bit about how you compare React Server components to GraphQL. They sort of solve the same sort of use case or same need, but they do it in different ways. And in my opinion, GraphQL is much better if you have a really large code base and a lot of different teams building something for similar web applications. But federation, which I showed you, or the one-to-many setup or many-to-many setup with your backend and your front-end code, isn't the only upside you get. There are some upsides once you actually adopted GraphQL and you start building your front-end applications. So, for example, in order to find out what those upsides are, we need to look at GraphQL clients, because GraphQL is much more than just an API layer. There's also a whole ecosystem of clients you can use in your front-end apps to easily interact with this backend layer. There's a couple of popular ones. You have Apollo client, you have Urkel, you have GraphQL hooks. And then there's one specifically, which is called Relay, which is really giving you more than just a way to retrieve data from an API. It's doing much more. If you think about GraphQL clients, how most of them work, you would have your React component tree. So let's say you have a GraphQL API that returns product information. And somewhere in your tree of components, you have a product list component, which is rendering different product components. And then the product components are rendering smaller subcomponents, because maybe you want to show reviews or pricing, or you have a cart component in there, which is doing other things. If you think about REST, or what most GraphQL clients do, if you think about where to send your request from, you probably want to do it from the product list component, because then you can drill the props down. Or you want to do it from some sort of state manager where you have context, or any sort of state where you retrieve the data from, and then you pull the data from the context. Most GraphQL clients or REST applications probably just use the product list component to pull the data and then drill the props down, which is perfectly valid because, well, you probably only need the products component in product list. Then you need all the individual sort of fields. You would need those in the subcomponents, and then the components underneath are using, again, a subselection of all this data. So prop drilling is a very popular thing in React. I always advise to not do prop drilling and use some sort of state manager, because it makes your life a bit easier. But let's assume for now people are still doing this. And I guess I'm still doing this sometimes, so you can call me guilty on that. So you're passing all these props around, which is perfectly fine. If you use a state manager, then you probably have a slightly different mental model. If you think about GraphQL, and let's say you're smart and you're not using GraphQL, but you are using a state manager, then you're probably off in a similar good shape. If you think about GraphQL with something like Relay, you actually go to a mental model where you have a state. Your state contains your GraphQL data, and each of the different components are able to retrieve part of that data. But they're doing much more. They're also dictating what types you actually need. So I think I have an overview of this. So what Relay is doing, Relay is really looking at your different components. It's looking at the props or the fields those components need. And based on that, it's compiling it into a GraphQL operation, which is then sent off to your server. So the mental model is slightly different. Instead of defining sort of your request to the data server somewhere central, you're actually writing your components, you're writing what types they need, and then this will be compiled into an operation that's sent to the GraphQL API. So all of these different components, they compile into fragments. So if you don't know what a fragment is, if you look at the GraphQL operation on the left, so this is to retrieve products. Then we're retrieving a subset of fields there, so retrieving ID and title and thumbnail for a product. Then we have a dependency to sort of child field, which is called reviews, and another one which is called pricing. You can use fragments to define what fields you need from one of those children fields. So what Relay does, it takes all those field descriptions or field definitions from your components, compiles it into a query like you see on the right, and then this will be used to retrieve data, and a Relay has something called a data store. So this is pretty similar to most state managers. And then the components are able to pull this from the data store. So it's more like a two-dimensional setup where you define the data you need in your components. The components transpile all those requests, all those requirements to a GraphQL query. The query will be sent to the GraphQL API. It will be stored in the data store, and then all the components can pull from there. So you're not doing any prop drilling. You're also not defining data centrally. Instead, it's really distributed, and you define data where you actually need it instead of in a central way. So Relay is pretty cool. If you're using GraphQL without something like Relay, I really advise you to have a look at Relay. It might be a bit of incremental work to get this kicked off, but it will really help you in the long run because it actually helps you to do GraphQL in a non-static way. So a lot of people are using GraphQL dynamically on the back end, but then really statically in the front end. So Relay is sort of making it simpler to take some of the dynamic approaches on the front end as well. And something else that's an upside from GraphQL, as I said in the beginning, it's like a secondary benefit. You can generate TypeScript types from the schema. And I mentioned in the beginning, some people might be using GraphQL wrong, because some people told me, why do I need GraphQL now that tRPC also gives me type safety? So getting TypeScript types from your schema is like a secondary benefit. It's a nice thing to have, but it shouldn't be your reason for using GraphQL. But once you're on sort of the GraphQL train, you should definitely generate your TypeScript types from the schema. I personally really like typed languages or having some sort of type checking in my code. So TypeScript really helps with this, whatever sort of front-end framework you might be using. And also one question to ask is, like, if you're using GraphQL in your application, but you're not using Relay, you really need to make sure that you're taking the benefit of GraphQL as a backend framework or a backend way of thinking, because otherwise you might not be getting all the benefits there are. So Relay is really powerful on the front end, but without any good GraphQL setup on the backend with federation or many-to-many relationships between front-end and backend code, you might not be getting all the advantages you would like to see. So GraphQL is really good in this data reusability. And then the final 10 minutes or so I want to spend on GraphQL and AI. You're probably all working with AI in some way, either using chat assistants or copilots or well, whatever is out there today. So I've been working with GraphQL for quite some while, and I really like, as a front-end developer, to have one unified API layer for all my backend code. So we've been doing some tests with GraphQL as sort of the entry path for LLMs in order to query different backend data sources. So if you would imagine a situation like this, where you ask a large language model, when will my package arrive? If you ask this to a large language model without context, they will say, I don't know what you mean, I don't know what a package is, or how to retrieve any packages. So that's why a lot of people are enriching the knowledge base of a large language model with like tool calling. So tool calling is where you give the LLM a list of tools, and the LLM can dictate what tool you should use in order to retrieve data from somewhere. And we've been using this together with GraphQL, where we, instead of passing the LLM a list of tools, we're passing the LLM a GraphQL schema. And the LLM is actually able to look at the GraphQL schema, and then based on your request, creating the right operation in order to retrieve data from the GraphQL schema. So in this example, I have a database which contains data about my customers. I have services like a REST API, which has data on my orders. And then you could start asking questions like, when will my package arrive? the LLM will look at your GraphQL schema. It will find you have something about orders in there and something about customers. And then it's able to actually generate the GraphQL operations that the system can execute or use developer can execute to retrieve this data. If you're using tool calling, you might have been using it with SQL databases or maybe OpenAPI or REST APIs in general. So one thing I noticed, if you send the API tools in different formats or different underlying schemas, like a database schema and a REST API, it's going to get confused because it can only do so much in a single turn. So if you ask an LLM to look at your list of tools and one of them is a SQL schema, you pass in a database schema. Another one is a REST API, you pass in the OpenAPI format. Another one might be GraphQL. The LLM needs to look at 3 different schemas for APIs. It needs to determine how to use those different schemas. It needs to generate something based on those schemas. It will get real messy real soon. So we've been playing with this. I can show you a small demo. So imagine you have an application like this, and I'm using Next.js, I'm using GraphQL, I'm using server components here actually as well on my sort of GraphQL request level. So we can ask the LLM, like, what tools do you have? And then it should return me a list of tools. I do believe the internet's a bit slow, so let's see what it comes up with. What it's actually doing, it's going to do a set of GraphQL requests. So it's looking at my GraphQL schema. Based on my GraphQL schema, it's going to tell me what tools it has. So there's one tool which is not GraphQL, and this is a JSON-ADA tool. So if you work with JSON, I would really advise to look at JSON-ADA. It's like a small utility library to transform JSON from one format to the other. So I sort of use this to transform data from one output of a tool to the input of another tool. So if I start asking questions like, what are the orders of John Doe at example.com? Then it's going to do a couple of things. The LLM is going to look at my question. It's going to look at my GraphQL schema. And then based on my GraphQL schema, it's going to determine what GraphQL query it should generate in order to retrieve the data. So it couldn't find this. So this happens sometimes as well because it doesn't always know how to generate the GraphQL query correctly. So let me go to my code, or actually go to my browser, where I can see the GraphQL sort of request it generates. So in here you can see it's generating a customer search query. It's trying to do this by providing an email address, but it's not getting any responses. So sometimes you need to guide LLMs a bit through what you're trying to do. So let me try and ask again. So try again, this time don't use quotes around the email address. There's still some human in the loop to be done always. So human in the loop basically means you have a human verifying whatever is going on. I do this after the fact. You probably want to do this before it actually starts trying to do this tool call. So now you can see it's trying again. I can see more data being generated here. And now it's actually able to retrieve data via my GraphQL schema from the underlying data sources. So it's good to know here, the LLM will only see a GraphQL schema. It won't see some bits are stored in MySQL, some bits are stored in REST API, some bits might be stored elsewhere. And I'm not writing any GraphQL myself. So I can actually see a future happening where maybe we're not writing GraphQL, but we have LLMs writing the GraphQL for us. Because one sort of comment I get from people looking at GraphQL, they find it kind of confusing to create the queries because they might miss some knowledge about using GraphQL, they might miss the tools to properly format it, and they might miss some visibility into how to get value out of the data. So the LLM generated a few GraphQL operations for us. So it's a query to retrieve a customer via an email address. It then returns the output, which is customer ID 1, and then it's going to use this to call another GraphQL field, which is now called MySQL_orders, with the retrieved ID from the previous query, and then all the fields that I want. So as a developer looking at GraphQL, I find it easy to read GraphQL schemas. And sort of the meta point here is that if we find something easy to read, then generally speaking, the LLM will find it easy to read as well. Because it's all based on NLP. So you can do much more here. I have some other tools built in. I'm not going to bore you with those today, because I do have another talk tomorrow. So 1:30 p.m., I think a room somewhere there, I have a talk called Large Language Models for Web Developers. And I'll be showing you a bit more about how to set up things like prompting or doing retrieval augmented generation, also tool calling with or without GraphQL. Then, as mentioned, my company was once acquired by IBM. We're building some cool developer tools here as well, so I appreciate if you could have a look. But most of this will be discussed in my talk tomorrow. So let me recap what we discussed today. Sort of the biggest point is don't try and compare React Server components to GraphQL one-on-one. You might be able to fulfill the same need you're looking for, but in very different ways. Because GraphQL is great for reusing data across multiple backend data sources. It could be front ends, could be backends, so where you have a many-to-many relationship between your front-end teams, your backend teams. That's where GraphQL really shines and helps you to get most value. If you have a one-to-one dependency of your backend and your front end, you're probably better off using REST APIs or maybe gRPC, or maybe use React Server components to directly call a database and skip the backend anyways. The declarative language of GraphQL is really helpful when you work with large language models or when you work with new developers that need to understand how to use your APIs. And React Server components are really for rendering or defining React server-side, whereas GraphQL is made for building APIs. So even though they might give you the same value, they have very different ways to generate that value for you. So here's some links in case you want to know more about what I'm working on. Feel free to find me well, somewhere here or add me on social media if you want to stay in touch. Thank you.